So yes, hello everybody, and can you hear me? I guess it's, is it this one or this one? Okay, probably both. So yes, my name is Hannu Krosing. I am been doing Postgres stuff forever, and since at least played around with 4.2. When it was, the language was PostQL, not SQL. Also, yeah, I mentioned that the oldest post on Postgres mailing list I found was from, what was it, from 1998, but I actually was there before, we just don't have evidence. I was going into really large databases when I was at the first DBA at Skype. I made batches for parallel vacuum, or basically vacuuming more than one table at a time, which was not possible at that time. We had all weird tricks around it, but then I made a batch and it became possible. Also, I invented the language PL proxy that I will also mention in this talk in the end for sharding and remote function calling. I have written 2 books, one admin book with Simon Wicks, and then the server programming book. Then I was quite long time for doing consulting for Second Quadrant, and then now last few years I have been at Google doing mainly Postgres and Cloud SQL things. The plan for this talk is give an overview what is database server, what is server-side programming, what languages are available, what are Postgres functions, what they can do, what are PL languages, and then I show how you can start using PL-v8 to run almost any language functions inside the database. And yeah, briefly I mention a few fun things you can do with PL proxy. So let's get moving. So if you think that database server is just for the place you store data, then you are using very small percentage of what it actually can do and what it's meant to do. Most of the work there is not for storing data. It's the classical ACID things. Basically correctness, control, organization, the things that are very hard to do as client. Postgres has put several hundred man years of development on making sure that these things work, that when you put something in database, then it's either all or nothing. When you put it, it's checked that everything is consistent by the rules you defined. Also, while you are working, then either everything is visible or nothing. And also, once you have committed, then you can be sure that it's there. And there are ways to make sure even if you lose a data center and have set it up correctly, it's still there in some form of backup. And how you use the database server. What you do is you have a client and you are sending your processing request to database. It can be initially you have to create the tables, set up indexes, all these. Everything is done the same way. You still send commands and get responses back. It can be data, it can be status. And I have seen lots of people who like object relational mappers or other things that hide these parts, but the hiding doesn't help you much because it's not SQL that is complicated, but the whole data management itself is the complicated process, which means that SQL is just the representation or the part of it you face, and you. In the end, you still need to understand what's going on, and SQL has the nice feature that it's the main one that is used for this. There are a few other languages, even the old Quell language, PostQL language, that do more or less the same, but SQL is clearly the most advanced, the most standard way to do it, and so yeah, I advise everybody to learn it enough that they understand, because even if you use object relational mappers or other nice technologies, the moment you start having problems, you need to still go deep and understand it. Also, now there is a big craze of no-code development environments. SQL is actually one of the oldest ones. You tell the system in an English-like language what you want it to do, and the system then figures out how to do it well, efficiently, securely. And there are now new ones coming up, some AI-based ChatGPTs and others who also tell they write code. And these are almost impossible to get correct. SQL is much easier. Once you figure it out, you can tell database what to do, and you can be sure that you actually ask the correct thing. So that's why this is just English-like, not any English language. But you can do only so much relational algebra and this set operations that SQL supports, even though I advise to do most of your database processing, not using that, just think it through, define what you want, and then write the SQL for it to happen in database. I have seen people who pull 100,000 tuples to their client, then run a loop over it, and then put it back. It is possible if you have a very capable server and very good infrastructure, but it's not the way I would recommend to do it. It has also all kinds of extra problems, locking, concurrency, all these are usually then not taken care of well, even though it's possible. And for that, you will use procedural language, which is kind of sequence of instructions, which is different from SQL, where you want to just say what you want to accomplish. In procedural languages, you tell the steps, do this, do that. And for high-level things, it's usually the right way to approach things. And it can be run in client, in middleware, that is something between client and database, or in the database. Or it can actually, you can write code that gets moved between these. So I quickly show a thing that I presented more than 10 years ago at a conference, where I wrote the decorator that took a Python function. Then it took the bytecode from the Python function, and it was sending it to a PL Python function in database, which unpacked the code, got the arguments, then put the unpacked code to the function it generated, run the function, return the result. And the decorated function looks like this. And it's, because it's decorated, it still look like normal function calls. So it also could be a way to organize so that if you have just a small amount of database-oriented developers, then you give others just functions that work. And the whole process took just a few milliseconds still, even if you send the code each time, which you usually don't do, you try to arrange it once. But it's basically the same thing you do with SQL. You send some code to the database, it gets executed, and you get the results back. Postgres, it's not just a database, it is actually a very capable multi-language development platform. And it's really flexible, configurable. Everything is defined in system tables, even a simple thing like addition operator. If you write select A plus B, then the plus is looked up in system catalogs. It knows that, okay, for these types, I need to use this function to implement the plus operator. And also typecast indexes, all kinds of access methods, type conversions, they all actually modifiable. Even Postgres comes with a very complete set, but there are still lots of things you can add or even change. One thing people quite often want to change, especially when moving from other databases, is some casts. For example, Postgres doesn't by default allow you to add to Boolean, but if you define a cast that implicitly or converts Boolean to integer, then you can do that. And there are other similar things that it's often easier than rewriting your code. You just make it behave more than the system you are coming from. It's not recommended as a long-term strategy, but to get the things over quickly, it's a very good option. And almost always what gets in the end called is a function. And you can call functions in any supported language for Postgres. Functions can call each other in Postgres, and the common language between functions is the Postgres data type. So the conversion always goes through the Postgres data types, even if the languages themselves have quite different ones. Like, for example, JavaScript has quite limited set of functions, but you can mostly emulate. If you are not doing too much precision work, then you still may find some extra implementations that have more precise types than the default ones. And what functions does Postgres have? It has a simple function. It's a scalar function, scalar, I'm not sure how you pronounce it, and scalar. And it's basically a function that takes one or more arguments and returns a single value. Then you have functions that return tuples or records. You can still think in Postgres at this as kind of scalar because in Postgres everything gets its type. If you create table, you get a table type that is actually a set of field values, and you can use it in many other places. When your type is required, it can also be a table row type. Let's make a distinction that if there is more than one value returned or a record, then it's another type. Then you can return tables, which is a set of record. It used to be only possible to say it's set of records, but for quite long time you can also create returns table and then say what fields there are. And then this type of function can be used anywhere where you otherwise would select from table. In from clauses, in with, as an argument to some functions that take tables. So all these can also use a function that returns table. It also can go the other way. You have aggregate functions that take kind of operate over a set of rows and then give a single value or a single record back. And again, all these can be defined yourself. I have usually been doing, there is a thing called advent of code that you get an task every day for the month of December. I have been trying to do this poorly in SQL, and often it was last year they had often the result was expressed as either kind of product over multiple rows. So I had to Postgres has a sum aggregate function, but it was very easy to also add product aggregate functions so that you could just go over rows and multiply them between themselves and get a large value out of it. And also there is a type of aggregates. There are two types actually. One is that go over the whole set. The other is, can go over sliding windows. For example, you can select also always compared to the last row. It's a built-in thing where you can, for example, compare that or calculate deltas, for example, on sorted sets and see at how much it changed. And then there are also functions that are used to implement triggers. They are denoted by returns trigger. It's actually not returned, but it's just to mark it as a trigger function that you then can use to define triggers. And there are also functions that are internal. So if you don't find the function description in documentation, then be more careful. At Skype, we had a problem that we used hashing functions for sharding, and at some point the Postgres community decided to optimize them, but during optimization they also started returning different values, which meant that now we couldn't find most of our rows. We solved it by actually making an extension that had old values, and then we were back where we used to be, but it was kind of surprise. I think it could have even come as a minor upgrade, or at least it got us unprepared. And then we had to figure out why suddenly everything is in the wrong place. So there is 3 kind of different large types of. First, there are C and internal functions. The only difference is that internals come with a system, and then C functions you bring in by defining them, and they are usually from. They are usually from the dynamic load library. Then there are PL functions, which basically means that you have a string that gets interpreted. This is how you define them. And then this string is passed to some interpreter after converting input arguments to the data types that this language understands, and the output is converted back. And for this we have the nice thing called dollar quoting, because the moment you have quotes inside the function, you have problem. You need to start double quoting them and then adding backslashes. And I think before the dollar quoting, sometimes the code had 4 or 8 backslashes to become out correctly after. But dollar quoting is a really powerful feature. I'll show a little more on the next slide. But then there is also a function type that is a SQL. And 2 versions ago, we also got a kind of standard SQL. The original SQL is defined similarly to PL functions, that it's part of the string, and it's interpreted when it's called. The ANSI ISA standard SQL is actually passed and checked at the definition time, and it's stored the same way as views as a forest of parse trees. And then the good thing is that as part of optimization, the SQL functions can be moved around in the query plan, and this can result in much more efficient plans. Yeah, here is a more complex example using dollar quoting. Dollar quoting, you actually can have multiple ones, and it matches between $2 a string, and then the end is same string. So here what I do, I have a function that creates adder functions, and you see that the outer function has $PL PGSQL, the function it generates. The format around it has SQL with dollars, and also the inner one is just double dollars. And so when I call this function with number 5, I get it creates a function add 5, and you can immediately use it. Similar techniques are quite useful for all kinds of introspection if you need to create some stuff, or sometimes you set kind of hand-tuned partitioning. You may need to create the partitioning function. So there are multiple cases where these types of things are useful. Also, functions have other types of properties. They can be immutable, stable, volatile. If you want to use functions as part of indexes, which is a quite powerful feature of Postgres, then they must be immutable. You can lie to Postgres, but you will then have problems if they actually doesn't return the same values at some point. Stable means that it's the same inside a single transaction, or maybe it was even in single command. Not sure which one it was. But basically it doesn't change while the query executes. And these are sometimes interesting. I was once debugging one query that was doing some quite large lookups, and I enabled PG statements, and then I saw that it was PG functions, PG user functions, and then I saw that for several hundreds of thousands of calls, the complex function was only called 3 times. And basically, if it's a stable function, Postgres can optimize it away and then just use the value in plans. And that's what was happening. Also, there are more kind of advanced things that you can define on your functions. One is leak-proof, which means that you can't use it to extract hidden data, like, for example, if you have row-level security enabled or other things. That it's more important in C functions, which could internally look at anything, because C functions are kind of all-powerful. And then also some functions are safe to use in parallelized queries, some are not. And yet another aspect of functions is that they can be either trusted or untrusted. Untrusted doesn't mean that they are flaky or don't work. It means that they are kind of very powerful. So like you don't want to give them to people you don't trust. It's about actually the trust to the users. Either they could be malicious or they would just be not very meticulous in their use. So these ones are there, and the samples of trusted trusted languages is Perl and DCL that are part of core Postgres, and also PLv8, which we cover later, which is also very good sandboxing. And untrusted ones are for Perl and DCL. There are also untrusted versions. Python has only untrusted version. There is no PL Python. There used to be, because people thought that they had sandboxed, but it, in the end it came out that
Excuse me,
Python.
no? Question.
Yes.
So I couldn't get what's the difference, like trusted and untrusted. We end up using C functions instead of SQL because it offers more stable behavior rather than the stable volatility. If we write a similar thing in SQL, we probably get in the volatile, but if you write similar thing in
they are not related. The volatility still says what you're doing. You can have also stable C functions, and you can also have volatile.
So if it is like a slightly complicated function, group by or something, so we observe that even if you declare it stable, it actually behaves like a volatile. But if we write the same thing in C, we couldn't figure out the reason, but it behaves like a stable.
Yeah. Let's talk about it later. It seems like interesting case.
Yeah. So, we try to implement something like what SQL Server supports, like object ID.
The language shouldn't determine if it's stable or not.
Ideally,
So it's more like a debugging case to understand why it's like that.
And also, so trusted and untrusted is another thing I wanted to just ask. What's the context of trusted and untrusted function being trusted or what?
Can you repeat the last question?
So what is the context in which we are talking about trusted and untrusted languages?
Basically, for example, no cloud provider actually allows untrusted ones, and it's mostly about being able to access local file system, send local signals, make TCP connections out of the system. These types of things that if you have kind of a secured system, you don't want to have this kind of backdoor.
Got it. Thanks.
But but you don't have any controls around C functions because they are low level, and you don't want to put this extra control around it. It would be really hard. And SQL is always trusted language. It only could get out of the sandbox by calling other functions that are not. So there are what PL languages are available. PL PGSQL is something that is always included when you install Postgres. You can remove it if you think it's a good idea. But it's very, very seldom removed. But sometimes I have seen people thinking that maybe it's better to not have it. And then both PL, Python, DCL, Perl, both U and non-U versions are also as part of the core. I think there was also a sample language, PL lolcode, but I'm not sure if it was part of core or was it something that was just provided, kind of.
It was an extension, I think.
Yeah, it was external extension, yeah. And then as third party, the ones I have seen actually used in production are PLR, PHP, PL Shell, PL Java. There were actually two versions of PL Java. One was in-process Java, the other was something that it calls out to a running Java server. And then PLv8. PLv8 is PL built around Google's V8 JavaScript engine, which is really powerful, just-in-time compiled JavaScript. It's for Google Chrome by Google, and it has teams working on it constantly, making sure it's high performance, stable. It is correctly sandboxed. We'll probably hear immediately if somebody gets out of it and can compromise Chrome. So most of this sandboxing is also available, applicable to PLv8. So you can be quite sure that it is a trusted language. And the library version of V8 is not versioned. It used to be that the team that did it kind of released also public libraries with the version. Currently, PLv8 code gives you instructions how to pull the latest version and use that. And at that point, when Google team stopped giving out this external numbered versions, then most Linux distributions stopped supporting PLv8. But PLv8 is available on all major cloud providers, and it's also quite easy to compile yourself if you want. So you just get to GitHub repo v8/v8, pull it down, and make sure you have dependencies, and the makefile does almost everything. It pulls the correct version of V8 code and compiles and installs. So it is not hard to do, but it's a little less hard, less easy than just installing a package.
Quick question.
Yeah.
Can you just go back to the previous slide? When was WebAssembly added? Was that a long time ago, or
WebAssembly is part of V8, and it has been there, I think, more or less. It was developed, while it was developed, it was behind some flags. Now it's kind of enabled default for a few years already. Yeah, but you still need to access through JavaScript and load it, and then the JavaScript is same as in browser or in Node.js when you want to use it.
Yeah, I thought someone might develop a PL WASM, but it's already now in there.
There is, I haven't seen PL WASM, but I have seen other kind of non-PL ways to use WASM that are also a few different experiments.
Now, is there a way to use TypeScript inside V8?
You should be able. I'll go in a few next slides. I'll show how you can pull in basically any transpiler, and then they are quite large, but so are it also in real life. So yeah, this is how you create PL V8 function. So again, $quoting inside. You create a function and apply. This is then taken and called by the PL V8 mechanism after internally compiling it. And JavaScript basically is a high-level just-in-time. It doesn't need to be just-in-time compiled, but all current versions in use are quite high performance and have all kinds of interesting tricks. And then if you run them more, they become faster, and there are parallel threads doing multiple different levels of optimizations, and there is lots of things going on. Yeah, initially it was actually started as a variant of Shim, but then Java came along, and it had to have, everything needed to be Java-like, and so also this turned into Java. And because there were lots of front-end developers, then at some point Node.js was created, which is server-side JavaScript. It was developed on V8. There are actually versions of other JavaScript engines, but not much used. PLV8 is only V8. It doesn't support SpiderMonkey or other engines, and also it looks like most browsers are also converging on V8, so there used to be more JavaScript implementation than there is now. And initially, the VAS was here. Basically, WebAssembly is a way to have a really close to real assembly way to describe. It's a virtual kind of CPU definition to which you compile, and when you load it, then it does a small transformation to your local CPU, but it still keeps it secure and inside your sandbox. If you install PLV8 source, either you compile it or also AWS has it, then you actually get two more languages, PL-Coffee and PLLS or LightScript. And neither of them there is no interpreter for them. They are done as transpilers, which means that there is a chunk of JavaScript inside the binary, and when you call PL-Coffee, then there is a very thin wrapper of around the PLV8 that just sets a flag and says, please run this code through this JavaScript. This is actually how the transpiler looks like. The first one is I ran it through Beautifier. It's actually lifted directly from the code. In the code, it was one single long line. When I ran it through Beautifier, then it was 12,350 lines. And then to actually make it do the transpiling work as PLV8 function, I had to add the last line. That the first part just defined the function, and then the last line calls it and returns it. And the right side is how you call it to transform a CoffeeScript into JavaScript. So you do select this function, then you give this CoffeeScript thing, and then it out comes the equivalent JavaScript, which you then can run. And if the system has this PL-Coffee installed, then it does it all automatically behind the scenes, but it doesn't expose the transpiler as a function. So it just happens. Same for LightScript. CoffeeScript and LightScript both seem to be things that are not much used. CoffeeScript at some point was quite popular because it had nice features that were not in JavaScript. At some point, even classes were not in JavaScript, which were added later. There was a different way of doing object-oriented things. But CoffeeScript had classes, it had sequence unpacking, packing, other things that were borrowed from Python and were quite nice to use. So a transpiler, they started out as things to just make different browsers JavaScripts compatible between each other, but then it grew from there, and there is now basically for almost any language you can find a few transpilers. They are of varying quality. Also, I found, I think, at least almost 10 different things that are Python-like, some more, some less. There are things that are more Python-like, also bigger. Some even include the whole Python library already transpiled to JavaScript as part of the transpiler. So there are lots of different things. And also for some they are geared towards speed, some are geared for making sure that the resulting JavaScript code is as close to original as possible, so that you can also read the resulting code. There are also things that can run, they are not directly transpilers, but there are also things that can take compiled Python files or JavaScript jar files and run them. Basically runners for bytecode files. So, and then to expose these things and make it possible for you to run yourself anything, instead of providing the PL things, no promises, but we are looking at making it available as just a flag to Postgres function definition. So once you have your JavaScript done, in any case, we will soon contribute it back to JavaScript itself, but we're not promising anything about making it available in Cloud SQL. So it's which I must always say when talking about future things. So, but basically, you just give the transpiler as a setting for the function, and then it gets called automatically. So you can have the original language code, and then you can add your own, whatever you want. And it doesn't need to be full language translation. It could be something like that interprets object relational mappers, or it can have some kind of embedded SQL. For example, you can have an embedded SQL that is interpreted one way if it's a client program, and the other way if it is something you run inside database, because the way to call SQL is different in PLV8 and in client, say Node.js. Node.js has multiple different libraries for interacting with Postgres. Or it can also some kind of simple macroprocessor replacing something in the strings. But basically, it's you just give a preprocessor for your code that is run before it is compiled into a runnable function. And it also does not need to be PLV8 function. It can be any function that takes one string and returns another string. So you could have something more efficient, maybe. You could even have, say, TSQL interpreter that converts it into JavaScript, and then you can write TSQL functions in Postgres. And we are almost done. I wanted also to talk another completely different type of PL language that we developed at Skype. It doesn't do anything itself, but it has the source code defines where to call the function. So it's a language for calling remote functions. And there are two other ways at least available in Postgres. So one is Postgres foreign data wrapper, where you can expose tables from other databases as local tables, and then there's a dblink, which has a set of functions for running queries remotely. PL proxy is something that you can just replace your existing functions with a proxy function, and you can get sharding, for example. We had to develop it because we ran out of vertical scaling space, and last I heard at Skype they were running, the largest instance was 60 nodes. And then they were, in total, they were running 5,000 Postgres databases behind PL proxy. So PL proxy also creates some kind of microservice architecture. Back then it had some other fancy name, service-oriented architecture, but basically what you get is you can call a function from anywhere, and it figures out on what database to run it, where to return it. It can run it on many databases in parallel and pull out, so you can do map-reduce type things. You send out, every database does something, then you pull it back and do the final processing. And all these things are quite easy to describe and do with not too much code. And in Cloud SQL, we have added, for making it easy to use locally, we have a flag, allow passwords as local connections, where I extended Postgres has already authentication method where it allows local system user to connect. So it checks the other end of Unix socket, what system user is there, and if it's the same user as they want to connect, then it allows it. I extended it so that it checks that if the other end is connected to a process controlled by the same postmaster, then it checks who is the logged in user, and if the logged in user is the same user, then it also allows it to connect without any extra checks. And this is long overdue to contribute back. I have promised to do, but haven't not yet done it. And yeah, there are a few use cases. This is the last one, so I take some more questions. But so what you can do in addition to this sharding thing, what is originally meant for, you can do autonomous transactions, which is a quite important thing for when moving from Oracle. People do a lot of autonomous transactions, so it means that inside your transactions you might want to do other things that are persisted always, even if you roll back the outer one. It's not complete picture because depending on your transaction isolation mode, you may not see the results after calling that. You should see the results in the normal, the standard is isolation mode. You can do writing from read-only replica, which is quite interesting use case. You define a function that actually connects to master and calls the writing functions there. So this is, and I have a version where it extracts the connect info from the replication string, from the connection string where it does the replication. So again, you don't need to do any extra configuration. It's just there. When you call the function, it automatically connects. It keeps the connection open for a certain period, not too long. But it can, and then once it's done, then in a few milliseconds you have it also in your local replica, because replication in Postgres is fast. Also, one thing which you can't do in Postgres, if you have a parallel query, then you can do writing only in the main one. So if you say do a function where you write to extract something, like you have a few terabytes of data and you want to write out what you sometimes write out, and you don't want to do it as a select, you don't want to as a select result, you may want to already see when it's going. Then you can make again autonomous PL proxy function that writes out it as an autonomous transaction, but you can't do it as PL PGSQL function writing, because it is not allowed to write in parallel threads for some reason, and it is not compliant to standard semantics in the standard transaction semantics in parallel threads. But you can, because it doesn't look like writing, you can't call the function that does the connection back and then writes the single things out there. This create table as select, Postgres becomes kind of slow when you have huge toast parts, and one customer had quite serious problems with it. So another thing PL proxy lets you do, it lets you, one way it is configured to do it, you can define a cluster and you can have an array argument, and then it uses the partitioning functions to split arrays into matching sets of each connection. And I used this one to connect back to the same database and then split the copy into small parts based on which is tuple ID deed ranges that is available in 14. And I think I tested up to 512 copy threads. Already with 100 I could actually get to the full speed, so that all the CPUs are used and done. But basically you go there and then have very many workers, and then it doesn't matter that a single worker is not very fast, because the aggregate still gets the work done. And the last one is sometimes I want to collect some statistics and you can't just run a tight loop in Postgres, because most statistics are updated only at the next command. So I made again a PL proxy function that makes a connection to another backend, and there it is a new command when you call a function. And without any extra effort, I got almost 2,000 samples per second if I ran full speed. You probably don't need that much for most, because actually the statistics are not updated that much. Maybe they are some 50 or 20 or 50 times for most PG-stat tables. But something from PGProc actually seems to be updated really often, and then you will get even at 100 times per second, I still saw that each of them had some data that was changed. So that's it. I have some links and also happy to take any questions.
If there's time, I'll ask one question. So very interesting presentation. Thank you very much. I was just curious if you had any thoughts about the changing use of SQL as a procedural language, I wouldn't call it so much procedural language, but as a user-defined function language, as it becomes more powerful, and as we have to do less procedural work with things like CTEs, window functions, and things like this, which have come along in recent years.
Yeah, it is really powerful. I think 2 years ago I did full advent of code that it has all kinds of interesting tasks. Some are actually sequential in nature, and even these it was possible to do with recursive function. I set myself a goal to do them in SQL, not in PGSQL. And almost all of were possible. A few needed to have an outer driver layer that called SQL repeatedly. But you can do really complex things using SQL because of all these features. You just need to transform the problem into kind of set operation space, and then you can do all kinds of searches and things. I actually have kind of pending thing for float search where I want to add union distinct on. Same as we have select distinct on. If you have union distinct on, then you can easily make sure that you don't search the same place twice, which you can't otherwise easily do. Then again, but all of them run reasonably fast, and then you can do really a lot by just defining what you want instead of writing code and then debugging that.
Thank you so much.
Thank you.
Thank you.
Mm-hmm.